the last lesson that we have for this chapter is talking about the applications of quadratic functions. So, as I just said, many applied problems involve finding the minimum or maximum value of a quadratic function, as well as where this value occurs. So we will distinguish between the two of them. And in this first one, we have a graph. And the nice thing about that graph is we're going to be able to check our answers against that graph. So you'll see where the numbers go algebraically and graphically. So this right here, an athlete whose event is the shot put releases the shot with the same initial velocity but at different angles. The figure shows the parabolic paths for shots released at 35 degrees and 65 degrees. In exercises 63 and 64 are based on the functions that model the parabolic paths. So the first one we're doing is number 63, and that is the 35-degree angle. And so that one is this blue one. So I'm going to go highlight that one. Okay, so we are, if my highlighter let me do this. Okay, this is the function that we're looking at, okay, that the shot put released, the whatever, the athlete released it. Okay, so they have already given us an equation right here, but they're asking us, and we're going to use that equation to solve our problems. I'm going to scoot up a little bit so we can see them all. What is the maximum height of the shot and how far from its point of release does this occur? Okay, so the key here is the fact that they're asking us for the maximum of something, okay? And the maximum of a parabolic function or quadratic function that we have talked about before. Remember, the max or the min occurs always at the vertex of the function, okay? And that vertex that we talked about on the last lesson was the x-coordinate is negative b over 2a, and the y-coordinate is what we get when we plug that in. Okay, so what is the maximum height? So in essence, what I'm going to do to answer these questions, I need to go find the vertex. So negative b over 2a is going to be, what is b? Remember, a is negative 0.01, b is 0.7, and C is 6.1, which I really don't need right now, but we'll come back to that. So B is 0.7, and A is, well, we got 2 times A, which is negative 0.01. Okay, so you're going to put that in your calculator, and hopefully you'll do that and come back and come find an answer of 35. And then I have to take 35 and plug it back in. So that's going to be negative 0.01 times 35 squared plus 0.7 times 35 plus 6.1. Okay, and when you plug that in, you're going to get that that is equal to 18.35. Okay, now that means that my vertex is 35 comma 18.35. And remember, whenever we have an ordered pair, this is my x and this is my y. Here is my x, okay, and here is my y. So the x coordinate is giving me the shot put's horizontal distance, and the y coordinate is giving me the shot put's height, okay? And if I graph this, if I go 35, which is about halfway between, and I go up to where he's marked that maximum height, and I go across, in my really bad line there, okay? Might fix that because I kind of got him a little bit low there. So if I go across here to match, okay, this is my x-coordinate. That's at 35, and 18.35 looks about where that is. So the question is saying, what is the maximum height of the shot? Well, this is the shot put's height, so that maximum height is going to be 18.35. I'm going to actually put it right here. 18.35 feet. Okay? And the next question says, how far from its point does this release occur? So that's the question that is asking us, where does that occur? How far from its point of release? And so that answer is going to be 35 feet. The next question, what is the shot's maximum horizontal distance to the nearest tenth of a foot? So in this case, they're asking us the maximum. How far did he go? So they're asking us, what's this number right here? How far did we get to? So hopefully you remember that's when y, this happens when y is equal to 0. So what I have to do is take this function and set it equal to 0. So 0 equals negative 0.01 x squared plus 0.7x plus 6.1. And I got to find out what values of x make that true. Well, that's solving a quadratic equation. I don't want to factor this, so I'm going to put it into my quadratic formula. I've already defined what a, b, and c are. So when I put that in, negative b plus or minus the square root of b squared minus 4 times a is negative, so I'm putting it in parentheses, a times c all over 2 times a. All right, and when you put that into your calculator, okay, you got to keep in mind the first time you're going to put it in negative 0.7 plus all of this, and you're going to get an answer of negative 7.8. And if you put negative 7 minus all of this, you're going to end up with 77.8. Okay, so those are your two answers. Does it make sense to have a negative 7.8? It does not. So this, see how that matches on my graph. Does that number match? And it does. That's close to 80, but not quite. So the maximum horizontal distance is 77.8 feet. Okay, and the last question that it asks, from what height was the shot released? Well, they're asking you what this height is right here. Okay, and that height can always be found because that's your y-intercept. So you just have to look at the original equation and say that's 6.1 feet. Okay, so you have several problems like that, or not really, have one just like that, and one where you actually have to draw the graph. And when you draw the graph, like you can just sketch it and just put in that y-intercept, draw your graph, your x-intercept, and then your vertex, and I'll be happy with that. And if you have any questions, you can ask me in class or when you see me next. Okay, this last one, only other example, you just have 4 problems to do. You have 100 yards of fencing to enclose a rectangular area. Find the dimensions of the rectangle that maximize the enclosed area, and then tell me what that area is. So, if I want to maximize the area, then I got to figure out how to calculate the area. So how do I calculate the area of a rectangle? Well, the area is the length times the width, and the length is, doesn't really matter which one I pick, 50 minus x, and the width is x. So when I multiply that out, I have 50x minus x squared. Okay, so I have to solve that, or actually, we could back up right here. If I'm trying to find the maximum area, look y'all, okay, and you'll do this exactly the same. Set it equal to 0, that's 50 minus x, and that's x. That's our zero product principle, okay? So to solve, I am not going to do that. I'm so sorry. We haven't learned that method, so we're going to go back with what we're doing right here, okay? So let's keep going. Let me erase that. I'm sorry. All right. So let's keep going the way we were. A is equal to, I have to set that equal to 0 and maximize. So A equals my x squared. Maybe I should rewrite this. 0 equals negative x squared plus 50x plus 0. So A is equal to negative 1, B is equal to 50, and C is equal to 0. So when I plug that in, I need the x-coordinate of my vertex, which is negative b over 2a, and negative 50 over 2 times negative 1 gives me 25. Okay, this is the x-coordinate of my vertex. It gives me the maximum area. And I do need to go plug that in because it did ask what the maximum area is. So if I go plug that in, then my area will be 50 minus 25 times 25. And that gives you an area. What I did, y'all, in case you can't tell, is I plugged it in right there. You can plug it into this one if you want. You'll get the exact same answer. I just think it's easier to plug it in here. So 50 minus 25 times 25 gives you an answer of 625. So to answer these two questions, the dimensions of my rectangle in this case happen to be 25 by 25. Okay, that should be 25 feet by 25 feet. And the maximum area is 625 square feet. Okay? Now, if you have any questions, come ask me. I found that x was 25, so if this is 25, then the other side is 50 minus 25, which is 25, and that's how I got my two sides. Okay? So, if you have any questions, come see me. You have 4 problems to work on your own.